So question 70, bit of fun at the traffic lights perhaps. No drag racing, of course, is allowed. I'm not condoning that at all, but it's an interesting exercise in what speed you need to attain before you can pass something which is going fairly slow actually. So there's the question. The first thing I'm going to do is draw a diagram initially for the family car. So a VT graph, and there's the family car traveling at its constant 8 meters per second. And then 1 second after the family car starts, I'm taking this point here as t equals 0. So 1 second later, the sports car starts, and that travels at constant acceleration, so it's a straight line going upwards until they meet. And I'm taking the time that they meet to be this value of time here, capital T. And when they meet, of course, the displacements are the same. So the area of the triangle is equal to the area of the rectangle. So the rectangle, which represents the displacement of the family car, is 8 times t. So I need to now find an expression for the displacement of the sports car. So I'm going to use the SUVAT equations, and the values in the SUVAT equations are as follows. So u is 0, the initial velocity, the acceleration is 6.5, but the time is t minus 1, because the sports car has, when it reaches that point, has only been traveling for t minus 1 seconds. When we put that into s equals ut plus half at squared, so this is the expression for the displacement of the sports car. So now we're going to use the fact that when they meet, their two displacements are the same, which means that the 8t is equal to the this expression for the displacement of the sports car. So that gives us this equation here. We can simplify that to give us this equation. Pop that into your calculator to get two values of t, which are 4.22 and 0.24 to 2 decimal places. So the answer to the question about the length of time the family car has been in motion is basically the value of t. That's what the value of t is, and so we can discount the 0.24 figure, and so the answer to that part of the question is 4.2 seconds. So now we need to know what the speed of the sports car is in miles per hour, and we're going to use v equals u plus at, another one of the SUVAT equations. So that gives us 20.96 meters per second, remembering that for the sports car, the time the sports car has been traveling is t minus 1. Then we need to just remember that we're being asked to give the answer in miles per hour. So converting meters per second into miles per hour, we multiply by 60 to get it into hours, divide by 1,000 to get into kilometers, and then multiply by 5/8 to convert some kilometers into miles. So the answer is 47 miles per hour. A little bit tricky at the end there, but hopefully you managed to get that one right.